In last class we were studying about the shear force and bending moment diagram. So in my last video I told you about what is force, what is shear force, what is moment, bending moment, turning moment, and types of beam, types of support and types of load. So in this class actually we are getting into the shear force and bending moment diagram, how it is calculated and how it is drawn. So before that, let us first go to what is shear force. Actually in my last video I told you that shear force is the force which is parallel to the deformed plane. That is in general case. But in case of beam, the shear force at any section of a beam is the force that is trying to shear off. Shear off means breaking or tearing. Shear off this section and is obtained from the algebraic sum of all forces including the normal reactions. Now I will explain this one. See, here it is a beam, okay? It is a simply supported beam as I had shown you in the last video. Whenever there are two supports are at two ends, those beams are called as the simply supported beam. If you observe at point A and at point E, two supports are there and it is a beam, and then there are three concentrated or point loads are acting at point B, C and D. So in this case, if I want to calculate the shear force, that means at any section, suppose I am taking any section here, that is XX. If I want to calculate the shear force at X, section X, then what I have to do, what these forces will do, if I am assuming that because of these forces, the member will break at point X, then how it will happen? It will happen in such a manner that, see here, support A, load at point B, and this one is support at point E and load at point B and load at point C. The member will break from here. These forces is called as the shear forces. That is either this side of the beam or this side of the beam or this side of the section or this side of the section. Algebraic sum of all the forces. See, these are the forces and this is the normal reaction. Algebraic sum of all these forces is called as the shear force. That means here I can tell that shear force is equal to algebraic sum of force at E plus force at B plus force at C, or I can tell that force at B plus force at A. Actually it should happen in such a manner, but the thing is that force is a vector quantity. So as force is a vector quantity, its direction matters. So if you will see, E force, the reaction at E is acting from bottom to top and the reaction at A is acting from bottom to top, and the rest of the forces at B, C, D, those are acting from top to bottom. That means these are the opposite forces. They will have opposite directions. So we can say that this Fe will be minus Fe plus Fb plus Fc, or here Fb minus F. This is in general sense. But in case of shear force, we have a sign convention by which we calculate which one is positive and which one is negative. So let us see that sign convention. In case of sign convention of shear forces, we used to follow a simple thumb rule, that is RUN, sign convention. We used to follow a simple thumb rule, that is RUN. R for right side, U for upward, and N for negative. If you remember this one, you can remember everything. That means if the right side of the beam is going upside, then we will take that force as a negative force. Just see the reverse of that one. If right side is going downward, means that will be positive. If left side is going upward, means that is positive. If left side is going downward, means that is negative. Here two things are there. Left and right opposite things are there. Up and down opposite things are there. Whenever the opposite things happen, the negative positive will change. If we will see the sign convention here, because you assume that in this right side section of the beam, this is the right side section of the beam. This is the right side and this is the left side. If I am considering the XX cross section, this is the right side section of the beam. In the right side section of the beam, just forget that force at C is there and force at D is there. So just because of force at E, what will happen? If any time the member will break means this portion of the beam will go upward. If it is going upward, then that will be negative, because right side member of the beam, if it is going upward, then that will be negative. That means reaction at E is negative. Next, see at point D. Just assume that only at point D force is acting. No reaction is there and no other force is there. Because of point D force, FD, what will happen if any time the member will break, this portion of the member will come downside. And this is the right side portion of the beam. If the right side portion of the beam is going downward means that is positive. Right side if it is going upward means that is negative. Whenever it is coming downward means that is positive. That means force at D is positive. Similarly, force at C, because of force at C, what will happen? The right side member will come downward, so force at C is also positive. Similarly, you see the left side of the member. In the left side of the member, if we will assume that only reaction at A is acting and no other force is acting, then what will happen? Because of this member will go upward. If left side is going upward means, if right side is going upward means negative means, left side is going upward means that is positive. Okay, so that means RA is positive. Similarly, if only force at D is acting, then because of this force, what will happen? This member will come in the downward direction. If the left side is coming downward, left side is going upward means negative. If left side is coming downward means positive. So force at D is positive. So next is, what is bending moment? Bending moment at any section in a beam is nothing but the moments which are trying to bend that beam. If we tell it qualitatively, that means, as you know, every force is having a rotational effect. So if you will see here a beam is there, two support reactions are there, RA and RB, and two forces are there, FC and FD. Each and every force and reactions is having a tendency to bend the beam about any section. So that tendency to bend the beam is called as the bending moment, if we tell it qualitatively. If we tell it quantitatively means what? Suppose if I want to calculate the moment about the section XX, that means the moment at section XX is nothing but the algebraic sum of the moments of all the forces acting on either side of the beam. Suppose if I am taking the right side of the beam, the moment of RA plus moment of FD is the moment acting at point XX. Or if I am taking the left side, then moment of RB plus moment of FC is the moment acting at the point XX. So as moment is nothing but its force into perpendicular distance, moment equal to force into perpendicular distance, and force is a vector quantity, hence moment is also a vector quantity. So as it is a vector quantity, here the direction matters. Unless and until we will not take the direction into consideration, then our calculations will get wrong. So for that one, here is also similar to shear force. Here is also the sign convention is there. The sign convention is in such a way that if the moment creates a bending like this, that is called as the sagging, and that is taken as positive. If the moment or if the force causes a moment like this, okay, just like a hat, then that is called as hugging, and that type of moment is taken as negative. If we will take this one, consider this side of the beam, right side of the beam. If only RA reaction is acting there, then there is a tendency that it will bend the beam in this direction. This causes a section like this. So moment due to RA will be positive. And if only FD force is acting, then there is a tendency that the beam will bend in this direction. This creates a section like this. So the moment due to FD will be taken as negative. Similarly, you will see here, because of RB, the beam may bend like this. So this is causing a section like this. So moment due to RB will be positive, and moment due to FC, similarly, you can see moment due to FC will be taken as negative. So these are all the sign conventions. The sign convention in case of shear force and bending moment is most important, because the sign convention only will decide whether something will be added or something will be subtracted. Next is shear force diagram. We had seen how to calculate the shear force in case of a beam. Whenever we are going to represent that shear force into diagrams, those are called as the shear force diagram. In this diagram, as the beam is expressed in terms of length, see, the beam is a combination of various points. At various points, how much amount of shear force is acting? That when we are representing by means of a diagram, that is called as the shear force diagram. In this diagram, in x-axis we are taking the length of the beam, and in y-axis we are taking the amount of shear force acting. And whenever we are constructing at various lengths of the beam, we are getting various shear force, and whenever we are constructing a graph to this, that diagram is called as the shear force diagram. Next is bending moment diagram. Similar to your shear force diagram, bending moment diagram is also a diagram where we express the various bending moments acting at various points of a beam. Suppose this is your beam, this is a combination of various points. At various points, how much amount of bending moment is acting because of various forces and support reactions. That when we express in terms of a diagram, that is called as the bending moment diagram. This is a diagram in which the length of the beam is taken in x-axis and your bending moment is taken in y-axis. That means here in the x-axis we are taking the length of the beam, and in y-axis we are taking the bending moments. That means at 0 length how much bending moment is there, at 1 length how much bending moment is there, at 2 length how much bending moment is there. Like this we used to take the bending moments at various points, and when we join the curve, when we join the points, the curve whatever we are getting, that is called as the bending moment diagram. So in this class, what we have studied, what is this shear force, what is the bending moment, and what is the shear force diagram, or in short we call it as SFD, and what is the bending moment diagram, in short we call it as DMD. In short we call it as DMD. So these much things we have studied in this video. In next video we will solve a problem for finding out the shear force and bending moment diagram of various fields. Thank you.